guys, to chapter 2 on particulate nature of matter, chemical formulas and equations as regards law of chemical reactions. The first question, an element X forms the following compound with chlorine. So there's XCl4, XCl3 and XCl2. This illustrates the one of the following law. This illustrates law of multiple proportion, which clearly means that a fixed mass of X can combine with variable mass of chlorine. So X is fixed. It has combined with 4 atoms of chlorine here, 2 atoms of chlorine here, and another 3 atoms of chlorine here, and 2 atoms of chlorine here. So the number 1 is option A. 2. An experimental test of the law of conservation of mass is illustrated in this diagram. In practice, the flask is weighted before and after the reaction between solution X and Y. Which of the following pairs of solution will be unsuitable for the experiment? The pair of solution that will be unsuitable for the experiment is any pair of solution that will cause for them to be an escape. Example, like an escape of a gas. So option E. Whenever you react hydrochloric acid and sodium carbonate, you are going to be having carbon dioxide, which might likely escape. So if the CO2 that will be produced escape, the entire weighted mass would not be the same as the mass as initially when the reaction was started. And the experiment is about the law of conservation of mass. So this reaction here, option E, there will surely be a loss of mass, a loss of CO2. So option E is not suitable for this experiment. Question 3. Now, there's something, our calculation series are done separately. So we are going to be skipping every calculation question. Number 3 is a calculation question, will be skipped. Number 4 is another calculation question on empirical formula, would skip. Number 5. A sample of an oxide of mercury weighed 1.00 grams. When this was heated, oxygen was given off and 1.00 grams of mercury metal was left. What is the formula of the oxide? Option E, none of them will be the formula of the oxide. This is because the entire oxide, when they say oxide, they mean oxygen and mercury is 1.00 gram. And they say when they heat that item, oxygen was given off and mercury is still 1.00 gram. So it's either the question here was wrongly framed or something, or the answer would just be option E, since you're having 1.00 gram here and also 1.00 gram here. We'll go to the next question, 6. In the reaction of oxygen with hydrogen to produce water, which of the following statement is true? The statement that is true is that 2 molecules of hydrogen will react with 1 molecule of oxygen to give us 2 molecules of water. So if you read through your answers, option E, 1 molecule of oxygen, this could either have been written as 2 molecules of hydrogen, just like I said it earlier. 1 molecule of oxygen react with 2 molecules of hydrogen to give you 2 molecules of water. Option E is the correct option. Option E is the correct option. Next, question 7. The number of atoms in 1 mole of a substance is equal to the Avogadro's number. Keep this in mind. 1 mole of anything equals the Avogadro's number, which is 6.02 times 10 raised to the power of 23. Number 8. In an experiment, 5.00 grams of a metal give 10.59 grams of its chloride. In another experiment, 1.50 grams of the same metal combined with 1.68 grams of chlorine. The above data illustrates law of definite proportion. Law of definite proportion. Option B, law of definite proportion. Number 9 has to do with calculation. We'll skip that for our calculation series. 10 has to do with calculation. Skip for calculation series. 11, skip for calculation series. 12, skip for calculation series. 13, skip for calculation series. 14, the ratio of 14, let's go. The ratio of the number of molecule in 2 grams of hydrogen to that of 16 grams. This has to do with a bit of calculation. Skip. 15, has to do with a bit of balancing of chemical equation. But the right answer here, the balanced equation, is option D. 15 is option D. 3H2O plus 2 hydrogen hydroxide would give you 6 molecules of water plus 1 molecule of aluminum sulfate. Option D. 16 has to do with calculation. Most questions on this chapter would have to do with calculation. We treat them separately on the calculation series. This also. 19, same thing. Let's go through question 20. The formula of the compound formed in a reaction between a trivalent metal and a tetravalent metal would be option C, M4X3. M4X3. Option C. 21 has to do with calculation. 22 has to do with calculation. 23 has to do with a bit of calculation still. 24, same thing. 25. In two separate experiments, 0.3625 still have to do with a bit of calculation. 26, calculation. We're stopping at 30, and the next video will continue. 27 has to do with balancing of chemical equation. The option is option C, 3, 2, 6, and 1. 3, 2, 6, and 1. This is similar to the question we treated just now on question 15. 3, 2, 6, 1. 28 is empirical formula. 29 has to do with a bit of calculation still. 30. A balanced chemical equation obeys the law of, I'd like you to jot this down. A balanced chemical equation obeys the law of conservation of mass, while a correct chemical formula obeys the law of constant composition or definite proportion. So 30 is option A. A balanced chemical equation obeys the law of conservation of mass. A balanced chemical equation obeys the law of conservation of mass, while a correct chemical formula obeys the law of constant composition or definite proportion. We'll stop here, and the next video would continue from question 31. Should you have any questions as regards this video we just touched, I would like you to ask your question on the WhatsApp group or drop your question in the comment section. Thanks for watching, and see you in the next video.